So in the previous video, we talked about the unit circle and a little bit, and I kind of just showed you kind of what it looks like. And although it looks really daunting, it's actually not that bad. There's a lot of good videos out there that can help you memorize them. How to do all of these different angles, how to memorize the angles and the degrees. So basically, what you're doing is that we were looking at a couple the functions sine and cosine, and we figured out that the sine of pi over 4 and the cosine of pi over 4 was square root of 2 over 2 and square root of 2 over 2. So basically, if I had the sine of pi over 4, so if I look at sine pi over 4 right here, here's pi over 4, you can see that the first value is square root of 2 over 2, and the second value is square root of 2 over 2. Now, this is what we call the unit circle. And when we call it the unit circle, the reason why it's called the unit circle is because the radius equals 1. Okay? So the radius is 1. So that means that my x value is our cosine. And my y value is our sine. Okay? So that's basically what it tells us. So that means if I wanted to figure out very, very easily, let's say I wanted to find what the cosine of 7 pi over 4 was, I can figure that out. All I have to look for is look for 7 pi over 4, which in this case would be right here. Let me draw it in a different color. 7 pi over 4, which is right here. Here is 7 pi over 4. And since our cosine is our x value, we're just going to go at our x value at 7 pi over 4. In this case will be square root of 2 over 2. So we don't need to be doing the 45, 45, 90 triangle over and over and over again. As tedious as that was, we can just use our unit circle here. Okay? So this is basically what you how you have it. Now, one cool way to kind of memorize this, well, notice that everything on the outside, here's a 30, here's a 60, and here's a 90. All of these are going by 30s. Okay? Same thing, 120, 150, 180, 210, 240, 270, 300, 330, 360. All of those are going by a pattern of 30 degrees. Okay? All of the middle ones, which is the blue ones, they're going by, they're going by 45 degrees. So 0 plus 45 gives me 45, plus 45 gives me 90, plus 45 gives me 135, plus 45 gives me 180, and so on and so forth. So the angles are really easy to figure out. In terms of the radiant angles, those are a little bit harder to look at, but there's many different resources out on the internet that can really help you out. And maybe during class time, I can show you a way that I can memorize the unit circle as well, and also how to memorize the outside coordinates, because you can probably see that all of them are kind of have a division by 2, and then you can see this 1, 2, 3 pattern. So there's many different ways that you can figure this out, but this unit circle is really, really useful, and you will be able to do a lot of cool things and find some angles really, really easily if you're able to derive this, and it's not really that difficult to derive. You just need a little bit of practice. So now right before we get into other stuff, let's just do one more problem. Let's just say we wanted to find the sine of 240 degrees. So what would that be? Well, instead of using your calculator, you can just use your unit circle, look for 240 degrees, which is right here. 240 is here. And we know that the sine is going to be the y value, which is going to be the negative square root of 3 over 2. Okay? All right, so that's basically what you do. Same thing with the negative angles. If you have a negative angle, instead you're just going to have to go down and you're just going to have to count a little bit, or kind of like think about the mirror image of the bottom part. So, and imagine if you're doing negative 45 degrees, you're going to look at 315 degrees, okay? And that's going to be your negative 45 degrees. So there's a lot of cool benefits to this, okay? Now let's just do one problem regarding sine and cosine, because we really haven't talked about, we've been doing it in terms of triangles, but there's another way that we really can figure out how to find the sine and the cosine instead of memorizing formulas. So the sine and cosine of an acute angle. And I'm pretty sure that a lot of you guys have heard of this acronym also. If you have this type of right triangle right here, and here is theta, then we can basically name a couple of these triangles. So for example, this is going to be my opposite side because it's opposite of theta. You can see here that it's opposite of that. This is what we're going to call my adjacent because it's right next to theta. Okay, and obviously the longest side is what we call the hypotenuse. Hypotenuse. So this is what we call the opposite. If you want to just write it down, adjacent, okay, and hypotenuse. So basically what it says is that I can think of an acronym to figure out what sine is. So sine is basically going to be the opposite over the hypotenuse. The cosine is going to be equal to the adjacent over the hypotenuse. Okay, and later on, I think the last section, we're going to talk about something called tangent. So there are other trig functions that we can do. The tangent is actually the opposite over the hypotenuse. I'm sorry, opposite over the adjacent. And the way that people kind of memorize this, there is an acronym that you can kind of memorize. And the way that you say it is SOH CAH TOA. Okay, so this is a way that you can kind of memorize this. So S stands for sine. Okay, it's opposite over hypotenuse. Okay, C stands for cosine. That's just adjacent over hypotenuse. Tangent stands for opposite over adjacent. So this is just a really quick acronym to kind of figure this out. So this is mainly if you can have something that's a shape of a triangle. It's really easy for me to do opposite over adjacent as opposed to saying, oh, this is just going to be the y over the r, or this is going to be the x over the r, this is going to be the y over the x. It's going to be really easy. It's easier to just think of opposite over hypotenuse, adjacent over hypotenuse if you have some sort of triangle. So let's do this quick problem, and then we can just go ahead and continue on with more trick stuff. So here is this question. So a straight kite string makes an angle of 40 degrees with the ground. If 250 of string, 250 feet of string has been let out, how high is the kite? So round to 1 decimal place. Okay, so let's draw a picture of this. So we have, let's say here's the ground, and we know that there's a total of 250 feet of string that have been let out for this kite. Okay, and it's making an angle of 40 degrees. Okay, and here's maybe the kite. I can't draw, so I'm just going to write kite. Okay, so you want to figure out how high is going to be this kite. Okay, so what is this height? Okay, so notice that you can basically draw a 90-degree angle here. Okay, so what you really want to figure out is, okay, so how am I going to figure this? So notice that I don't have this side. So what we can do is try to figure out what is my opposite, my hypotenuse, and my adjacent side. So we know that based on this triangle, my opposite is always going to be the thing that's opposite or away from the angle. So this is going to be my opposite. Obviously, this is my hypotenuse. This is going to be my adjacent. So notice, what is the thing that we know? Well, we know we want to figure out our opposite, and we have our hypotenuse. We don't have our adjacent. So what's opposite and hypotenuse? Well, if you think about it, well, what's opposite of our hypotenuse is just going to be my sine of theta. So we know that sine of theta is going to be equal to the opposite over the hypotenuse. So sine of theta, so theta in this case is 40 degrees. I'm going to write 40 degrees here. Opposite is just my h over hypotenuse, which is going to be 250. Okay, now what you want to do is solve for h. So I'm going to multiply it by 250 over. So I'm going to multiply 250 to both sides. So that's going to go away. So my h is going to be equal to 250, the sine of 40 degrees. Okay, so then when you put this into your calculator, which I will do in the next video, this is going to be 160.7 feet. So this whole thing is so the kite is 160.7 feet up. So in the next video, I'm going to show you how to put this into your calculator and also change your mode from radians to degrees.